Welcome to Honors Geometry Lesson 3.6, where we talk about theorems about perpendicular lines. We've spent most of this chapter so far talking about parallel lines. Now we're going to talk about perpendicular lines. Perpendicular lines, again, are lines that intersect to form right angles. So let's get right into it. If two angles form a linear pair of congruent angles, then the lines are perpendicular. Okay, I'm not going to spend a lot of time on a two-column proof to show you how this theorem works. Instead, I'd just like to walk through exactly what's going on here and just leave it at that. Alright, so what you got here is two angles that form a linear pair because their non-common sides are a straight line. Okay, the linear pair postulate says if two angles form a linear pair, then they're supplementary. So our equation is x plus x equals 180. 2x equals 180. Divide both sides by 2. X equals 90. Okay. So both these angles must be right angles because their measures are 90. And that's the definition of perpendicular lines. Lines that intersect to form right angles. Alright, let's go ahead and move on. If two acute adjacent angles have sides that are perpendicular, so we've got a right angle symbol here. So that means that these two lines are perpendicular to each other. And you have the side of angle 1 right here and the side of angle 2 right here. They're perpendicular to each other because vertical angles are congruent. So if you have two adjacent angles whose sides are perpendicular, then angles 1 and 2 are complementary. And of course that makes sense because this whole angle is 90 degrees. So 1 plus 2 has to equal 90 using the angle addition postulate. So that means that 1 and 2 are complementary. Not real complicated, is it, so far? Alright, let's move on. Okay, if a transversal, that would be this line right here, is perpendicular to one of two parallel lines, then it's perpendicular to the second line. And all we'd have to use is the corresponding angle postulate to get this angle right here to be 90 degrees, a right angle. So the transversal is perpendicular to the second line as well. That would not take much in a two-column proof to prove this theorem. Let's go ahead and move on. In a plane, if two lines are perpendicular to the same line, then they're parallel to each other. So we've got two in this picture. We're in the plane of this screen. We have this line here perpendicular to this transversal, and this line is also perpendicular to that transversal. Well, using the corresponding angle postulate, okay, we're going to make this a right angle. I guess using the linear pair postulate, these two have to add up to 180. Now using the corresponding angle converse, we can get these lines parallel to each other. Now, the reason that the first three words in this theorem are important in a plane, because you can have two lines that are perpendicular to the same line but not parallel. They would instead be skew. Make sure you ask me in class to show you a pair of skew lines. They're not perpendicular, but they're not parallel, but they are perpendicular to the same line. Remind me to show you that when you get into class. And I do believe that this actually concludes Honors Geometry Lesson 3.6, some little theorems about perpendicular lines. Thank you. Have a good day, and we'll see you in class. Don't forget about asking about skew lines. Bye-bye.